Okay, so today we're going to try something a little new and a little different. You can see I'm holding on to something to write on. It's a Surface. And I've also got my other computer set up, and so you see what you're seeing is the student view up here. And we're trying to see if this will help us get a cleaner recording where we can put the student view up using our laptops and then have the Surface right in front of us to get the microphone better and get the sound better on the other end for those people that are, maybe for you if you want to go back and review the recordings, or for the people that haven't aren't in the session that need to listen to the recording. So we're going to try this today and see if it works, and we get to be the first group to try it. So that's why you're seeing what you're seeing, and that's why it says teacher up there, because I had to, I'm the administrator on this one, but I had to sign into a student account for that one. So that's why that's like that. All right? So we're going to get started, and everybody got their height and their shoe size up there, right? So we're going to use that for a little activity. Hopefully we'll get to that activity today. And we're going to actually kind of get you actively involved with actually making some things. So we're going to say goodbye to Mr. Hayden's High and go to our integrated math piece today. And today we're going to talk about two-way tables, scatter plots, and something called association. And they all kind of tie together, which is really nice because then we can kind of talk about all of them as we go through fairly quickly and hopefully get through everything today in the lesson. Just remember also you've got a test coming up for this unit. I think it's on Monday, so kind of keep an eye on that. One thing while you're writing the essential questions down here that you need to keep in mind is, there's a part 2 to each test, and for that part 2 in each test, what I'd like to see everybody do is make sure when you get it to do as much as you can on the test. Okay? Don't just put it aside and not do it because maybe you don't understand something, but do as much as you can on the test and get at least some points with everything, because some points is better than no points, right? And then also I want you to, as well, that provides you with an opportunity to either get some extra help from me and retake the test, or so you can even get more points. If you don't do the test at all, then there's no retake opportunity because you haven't taken it in the first place. Okay? So keep that in mind when the part 2 comes through on the K-mail. Okay? So there's 2 questions? Yes. Okay. Looks like pretty much everybody's just about done with writing those down. Okay, if you didn't quite get it, maybe you can look at your neighbors for a second and finish it up. We're going to go ahead and move on. There's quite a few vocabulary words that you're going to be seeing either in your online lessons or talking about today. So let's get some of those down. Make sure you leave some space to write the definitions or write things down about these things as we go through the lesson today. pretty much everybody's just got that down, or their neighbor does, so they can get from their neighbor. So, we've been talking a lot about like mean, median, and mode, and all this stuff with dealing with data, right? And so we've talked about working with that data, but we haven't talked about organizing that data. So that's what our big idea is today, is organizing data. So one of the things you need to know is we've been kind of dealing with data that's fairly simple. There's not lots and lots of parts to it. But when we get some data that has several categories, we're going to have to figure out some ways to organize the information that builds on some of those simple methods we've used, just like it says there on the slide. So I'm asking you guys the question. I want you to think about it for a minute or so, and then think about what are some methods we use to organize data. Okay, so just think about it on your own for a second, and then I'm going to ask you to share with your group and then share out. What are some ways we can organize data and to share that data with people that makes sense? And maybe it's easy for them to kind of be able to look at and read and interpret. No, it's this. Yeah, if I'm not at the back of the room, it does that. Just you guys can maybe reach over and just on the mouse pad. Okay, so what do you think? Share with your group. What kinds of things do we use to organize data? Share with your group. What do you guys think? What do we organize data now? Nothing? Nothing at all? Okay, I've heard several things come out, so let's share around the room. Let's start, just share one thing you guys came up with at your table. Histograms. Histograms, good. What else? What did you guys come up with?
The three mode median.
Okay, that gives us that tells us about the data. That tells us information about the data. Okay, but how can we organize some of that data? Okay, basic histograms. So about over here, what did you guys come up with? Something.
Graphs.
What kind of graphs? Because there's lots of kinds of graphs. Anything special in your head? Anything special? How about you guys? Can you think of a special kind of graph?
A line graph.
A line graph. Good. What else? What other kinds of graphs are there?
I don't know.
There's line graphs. There's
Bar graphs.
There's bar graphs. What other kinds of graphs are there? We had histograms. Those are kind of a special kind of graph. Okay. So we've got bar graphs, line graphs, that kind of stuff. Any other way to organize the data? Pardon? Okay, least to greatest. Good. And that we had to do that in order to be able to do this. Okay, put it in order. What other ways can we organize the data? Okay, so far you've said bar graphs. Isn't that much nicer writing now? You said line graphs. You said histograms. You said least to greatest. We said we've used before Okay. Stem and leaf plots, right? Haven't we used those before? We talked about those, right? What else have we talked about? Stem and leaf plots, and what else? Okay, well, let you think about it, and let's go ahead and go on, because we're going to use some of these ideas today. Oops, too far. Okay, so how much? Oh, the other thing we did is we had tables, right? We can organize things in tables. That's something I wanted to bring out because that's what I want you to kind of think about today. So how might you organize this data in a way that is like in a table? It says the LA Lakers won 13 games and lost 40 games so far this season, which is true. I just looked it up before I did this yesterday afternoon. And the LA Clippers have won 35 games and lost 19 games this season so far. So how could you create a table? Because this is a little bit more complex data. We've got several pieces to it. So how could you create that? Go ahead and try it. How would you think about it and talk about it in your group? Maybe just come up with one table as part of the group. How that might work. Okay? How might you organize that and put that information in a table that would be easy for somebody to read? See, we have the extra name tags in here somewhere. Did I put them away? There we are. Okay. Somebody has a thought. I had a couple people have some thoughts. Okay, sure. Make sure you work talking with your group about it. Share what do you think? How do you think that could work? And some of you are kind of sitting waiting for me to do the work, but I want you to think about it. So what do you guys think? What do you guys think in terms of the table? How would you make a table for that? It's not about if you know how to do it or not. How do you think? How do you make a table? I said. How could you organize that in a table? So what information do you have?
The win-loss ratio of each team.
Okay.
Like you know how the graphs work?
Okay, we're not making a graph. We're making a table.
Like a T table?
Could be. Try it and see. See if that's going to give you everything you need. This is your opportunity to try something and see if it might work, and maybe you'll be right. And it's okay if you're not right. Okay, you guys all agree here? Did you share? Share and see what you guys got. So what did you guys come up with?
We couldn't remember the name for it. Search someone who's like.
Is it okay?
The LA Clippers I think we have one more game.
Okay, well, that's okay. That doesn't make a difference. We're not trying to do anything with the data. We're just trying to put it in an organized way. So, let's see. We've got a group over here. I'm going to let you draw a picture of yours up here. I'll just do it like right in this corner here. Okay? Okay, great. How many have something that's like that? Pretty much. I know you guys agreed at this table here. Did anybody have something different than that?
That's pretty much the same.
It's pretty much the same. How is yours a little different than that?
I was just going on the top and side.
Oh, so you put the Lakers and Clippers at the top where it says win lost,
Mhm.
win lost, and then put the other part on the side. Okay, so it doesn't make a difference whether I put this right here, this right here, up here, does it? I could reverse these, or I could reverse those, couldn't I? The numbers would change where they would go, where the numbers would go would change, but I can put the labels in either place when I start the table, and that's absolutely correct, okay? So good. And this looks basically exactly like what it said. Just identify those. Okay, so to create a two-way table, the first thing you're going to do, the first thing you had to do was identify the categories, right? So once you've identified the variables and the categories, then you could set up the table and fill in the table. So that's how you create a two-way table. And once again, I asked you guys to kind of try it yourself, and basically just about everybody in the class was able to, after thinking about it a little bit, create the table you were supposed to create. So you were able to do the math without a whole lot of help from me. So that's really good. Okay? Looks like most everybody's just about done with that. Okay? So again, like I said, you can reverse the label placement on the table like we did before. But then, let's see, I'm trying to remember what was the wins for the Lakers. Wins was 13, losses was 40, right? And Clippers won 35 and lost 19. All right? So once you have things on the table and organized, then you can answer questions about the information. So it says, how many games has the Lakers played? And you guys somebody started thinking about that already when I asked you to make the table, right? You started saying, well, the Lakers have played more games than the Clippers or vice versa, and those kinds of things. So, because you're looking at the numbers, or like one of the teams had played one more game than the other team, and you're already looking at that with the numbers, but when it's in the table, it makes that. So you can answer questions like this, like how many games have the Lakers played, how many games have the Clippers played. So do that, figure that out. Let's answer those questions based on the table. Let's start with the first one, though. Let's do one at a time. The first one.
Oh, you want to answer this question?
Yes.
Okay.
Okay, so what did we get for total games? What did we get? Emily, what was the first one? For the Lakers, yep. The Lakers won, or played 53 games, and the Clippers, Cody, what did the Clippers play? 54. So we can ask another question, is how many more games did the Clippers play than the Lakers play, right? Now, the percent of games, how do you figure out percent? Divide what? Okay, the 13, say 13 divided by 53, because it's the number of wins out of the total amount, right? Mm-hmm. Okay, so somebody's already told me that for the Lakers it would be 13 out of 53, which I can change to percent, right? Okay, how about the ratios of wins to losses for the Clippers? 35 to 19, excellent. And if I said losses to wins, it would have been 19 to 35. Okay? So some of those things are starting to kind of come back to us in our heads. Okay? And then you guys also talked about bar graphs. Okay? The reason I go ahead and changed it, even though some people may not be quite done, because I wasn't so worried about having the exact answer there, guys. I was more worried about that you could look at it and give me some information. Okay? So bar graphs. There's two kinds of excuse me, that's not right. Two kinds of bar graphs for two-way tables. Okay, I didn't say that really well, did I? There's two kinds of bar graphs for two-way tables. There's a side-by-side bar graph and then the stacked bar graph. Okay? So take a second and look at those bar graphs up there and think about how are they the same and how are they different. And just kind of jot a little note down to answer that question. How are the bar graphs the same and how are they different? And so think about it on your own for a couple of minutes, and then I'm going to have you share with your tables, and then we're going to share out. Okay? I see some of you are putting some of this information in with the definition or parts of the vocabulary words to help remember what those things are, which is good, because that information is a good place. You can go there, but you can also put some information up with the other pieces. So how are they the same? How are they different? Are you going to need another piece of paper?
No, go right there.
No, it's just sometimes maybe turn it over if you need to. And, let me put it in here. Okay. All right, so some of you just kind of copying what's up here, and that's fine. But hopefully you've been thinking about what I asked you about, because I want you to talk with your group now. How are those two bar graphs the same and how are they different? Talk with your group.
Bar graphs is probably the same visual as you see the first one. Bar graphs on the side. Yeah, and second on the right, you have to do it. So they might mean two different things like that. So it's very varying on that little.
Okay. How about the rest of your team? Do they agree with you?
I think we're the only common one.
That's okay. So, so you guys make sure you agree or disagree with these guys. Okay. So what did you guys find out?
Well, what I was trying to figure out is that the left side, that bar graph seems a little bit more easier to understand because it's a little, because they're side by side, and this one on the right, it shows that both bars are on top of each other. So that might make it seem like in total, in all birds, it equals out of all 10 birds. And then the one on the left is just like separate.
Okay. Anything else you guys saw and noticed? No, you don't have to answer.
The one on the left was the side by side and the one on the right.
Okay. So that's how they're different. How are they the same? Okay, so look at it and think about it.
They're both suburbs.
Okay. What do you guys figure out? What do you notice about them being? How are they the same? How are they different?
The one on the right has more room.
Okay, what do you mean? Why?
Like, since there's size, you can add more data if you
Okay.
have more.
Okay. Certain kinds of comparisons, one would be better than the other. It might depend on the kind of comparison you want to, right? Which one's better? Okay, good. What else? Anything else? Think about how they're the same too. What did you come up with?
They're both the same except for the right one. They're stacked.
Okay.
But they're the same thing. The left one isn't stacked.
Okay. So you're telling me they're giving the same information? Okay. All right. Okay. So let's share some things around. Let's start with this table right here, and we'll go around. Okay? Go ahead.
The main difference between the two stacks, the one on the right stack, that is actually added to categories or ball graphs together.
Oh, okay. So they took the ones that are side by side and stacked it on top of the other. Okay.
Yes. But the thing is the fact that they still have the two different categories, but it's much more obvious which one is bigger and which one isn't.
Okay, so they both have the same categories, and when you say obvious which one's bigger, which one's isn't, what do you mean by that?
Right, you can see that the one on the left, on the ball graph on the right, they added the two together instead of the one on the left, but you can still see that it's probably bigger, but it would be better to show when they're stacked.
Okay. When would it be better to show that when they're stacked? Why don't you guys think about that? Go ahead.
When you're trying to count the total birds in the environment or whatever it is.
Okay, that would be better for the stacked ones. Okay, can everybody see that? That the stacked one is going to help us see the total numbers better. The other one gives us more information about how many of each bird is more quickly figured out, isn't it? Okay, so sometimes one's better than the other. What else do we notice? Over here, you guys share something else? Did you have another thing you guys talked about? Okay. Over here, what did you guys notice? You had a couple good comments that they haven't said yet. Go ahead. What were you guys talking about? You had some really good things you told me. I need to hear it because they haven't talked about it yet. Help them out.
right one is better for comparison.
Okay, the right one's better for comparison in terms of,
This is the one side.
okay, for the total amounts of birds, good, excellent. So the right one's better for comparison of total amounts of birds, but the left one will be better for comparison, what, how? Why? Because you could compare with the left one too, right? Correct? Okay, but what would we want to compare in the left one? I knew it was going to happen. Anticipate that. Let's look at that. What does the blue mean, guys? What does the blue mean right here? I'm talking about the Blue Jays, and the red means the Cardinals. So if I'm looking at that, I'm looking at my blue right here and my Cardinals right here. What am I comparing? Yeah, how many Blue Jays are flying versus how many Cardinals were flying, right? And this one's going to be talking about comparing the Blue Jays to the Cardinals, isn't it? Where here, we're looking more at the total number flying and perching, right?
And then the first one we compared, and then the second one they just added them together.
Mm-hmm. Yeah.
So the second one would be used better for overall data.
Yeah, and the first one was ready for comparison.
Okay. Excellent. Those you guys are coming up with some good things. Is everybody hearing what they just said over here? How some, you know, we want to choose our, basically we want to choose our graph based on what we are going to be comparing. And in this case, we're comparing quantities here, or not quantities, we're comparing categories. Blue Jays and Cardinals and flying versus perching are categories, aren't they? Okay? And that's why we have the bar graphs the way they are, because we're doing categories. Although we still have some numbers we're talking about numbers within those categories, in several categories, all right? And basically, all you did was take that pink or red for the Cardinals and take it and move it and stack it on top of, so you just took it and stacked it on top of one. So you just took this and went, put it right there, and then we had our stacked graph, right?
Yeah.
And took this one and went right on top of that one, and we have now a stacked graph. Okay? So do you guys want to, is there any notes you need to write down and thoughts you need to write down about this before I go on? Or as I'm ready to go on, so you have thoughts about if you have to go back and do this for on the test? Okay, so now, remember I said that another way to organize the data is stem and leaf plots, and we had that second extra set of data that we're not used to, because usually what you're used to seeing is, in the stem and leaf plot, is something like that, right? And that's all you're looking at. But sometimes when you have extra sets of data, and you've got that second piece, you can make your stem and leaf plot go in two different directions. Let me just show that, like it was showing here. Because in your table there it says age, it gives you the ages, and that's what those numbers are. But then you also talked about how old are they, and do they like the original version of the movie or the new version of the movie? And so you can make your stem and leaf plot show that information. So over here, those are the ages of people that like the original version of the movie, and in this case you're kind of reading it backwards, because this would be 35, right? This is our tens place here, and this is our ones places here. And then the new version is over here, on that side, okay? So you can kind of organize it in two different ways there as well. I don't necessarily want to spend a lot of time on that because you guys know, I know you know how to make a stem and leaf plot, and you can just see that it's going in two different directions. You just have to label the top, original and new, as in this case, so we know which numbers go with which category. So this has some categories and then some quantitative information by the age. You can see that they said that up here. The ages is kind of numbers, and the version was a category. So we had to think of another way to get that information out. Okay, so just kind of a quick thing. Then we've got scatter plots. And it's kind of like line graphs, but it's not quite. Okay, and scatter plots are both when you have two things that have sets of numbers. Okay, quantitative and quantitative, that's numbers. So we have elevation and we have snow, and that was graphed on there. So why do you guys think I asked you to do your height and shoe size today? Because you're going to do a scatter plot, exactly. Okay? And so to create a scatter plot, you have to determine the scale for the horizontal axis. The scale is how you number it. And when you number it, remember you have to be consistent in how you number. So if you count by ones and everything is 1, 2, 3, 4, 5, 6 all the way, or if you could count by twos, that's the scale. Then you have to determine the scale of the vertical axis, and then you have to plot the ordered pairs. So, did everybody put, I don't think everybody put their height and shoe size up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't see 14 stickers up there. If you have them, go put them up. Height and shoe size. You need about 6 more. No, you need about 5 more. Okay. And so the question while we're getting that up there is, when do we use scatter plot to organize data? And the answer, I already answered that question, is when we have two quantities of things, where we're actually working with two sets of numbers. And we've got lots of them. Okay? So your job today is going to be kind of to sketch out a little scatter plot of this data. And I'm going to read this data off to you so you can write it down. And I'll put it, actually I have to write it down. And then I'm going to ask you to create the scatter plot. Yeah, you're going to probably want to do it on a separate piece of paper. Okay. So I'm going to actually cover this up right now. Okay, so we're going to compare shoe size and height to see if there's a relationship. So let me give you the information. I don't have everybody's here, I know that. So I've got height. I'm going to write these down on here so that people on the other end can see. We've got height, and we have shoe size. So the first height I have is 64 inches and 8.5 shoe size. The next one I have is 66 inches, 7.5 shoe size. Then I have another 66 and 8.5. And 71 and a 9 and a 70 and a 10.5 and a 67 and a 9 and a 72 and an 8 and then a 67 and a 9, 80, oops, that's not right. So this should be 61 and an 8. Then we have a 69 and a 9. Okay. So let's have that, go ahead and start working on making a scatter plot. Figure out what kind of scale we need. How are you going to number the part where it says height, and how are we going to need to number the part that says shoe size? Look at your numbers and see what we've got.
Well, we have one extra shoe size. What is that for getting an account?
No.
Someone has a third foot.
Okay, I'm not the only one. Oh wait, no, there's
1, 2,
69.
3, 4, 5, 6, 7, 8, 9. Oh, we match up.
Yeah, it matches up. I just was missing the.
Yeah. Okay. So I have you guys think about that. I know you don't have graph paper, and that's okay. Just kind of sketch it out. It doesn't have to be exactly perfect because it is a scatter plot, but. So how are you gonna number your height axes based on what you see there?
By 10.
Okay, possibly.
Or.
Possibly by 5. By what?
By 2.
The height? Why would you do the height by 2?
Because it was like 56, 54, and 57.
Okay.
Well, take a long time.
Mhm.
Or you can start by 60 and go by.
Okay, what do you think about what he said, Wyatt? He said it would take a long time to get there by 2s. Yeah. So you have to know how to make the graph so you can do that. Okay. So that was a good thought too, is do you have to start the graph at 0, totally at 0?
You?
That's a good question. What do you think?
Got it. No, you can.
Mm-mm. Yeah, you can. If you want to, I'm not sure, whatever axis you choose, it doesn't make a difference. What you can do, I'm gonna actually make it the vertical axis. What you can do is start it up and then kind of do a little squiggly like this and like that. Just that says you're skipping numbers because you're starting 0 here, then you're gonna skip up and you can start like at 60 or whatever you want to start with. You just say 60 here. And then could you do it by 2s like Wyatt suggested?
Yeah.
Mm-hmm.
And
Okay.
then for the foot, we could just go by a foot each.
Okay. Or you could do halves too, couldn't you?
Well, that's still going to take a little while to get over.
Okay.
It would just be a long.
Yeah. Or you could do 1s. Yeah, that would work too.
Alright.
Okay. So good. Those are good conversations you guys are having about that and what you're doing and why you're doing it. That's important to think about that.
That's 2 meters for each.
Yeah. So actually when you do that, you don't have to put the 2 there, you just have to put the inches.
Oh.
Yeah.
Sorry.
Then just make go by 2s on the side.
Yeah.
Okay.
Is it cool if we organize?
Mm-hmm. If that helps you. Just make sure the 2 numbers stay matched up. make sure you keep this number here with the 61 with the number here. Okay. Right. You want to do this? Okay, so this is going to be your height. Are you going to make a little break? Like, yeah, you made a little break. So what would this number be here? Should we start with 60? Okay, so 60, then what? Divided by 1s, divided by 2s. So you got to go from 60 all the way up to 71. Do you have enough to do that by 1s? You gotta do it, and you can't just put whatever numbers are there. You gotta like start with 60, then say 61, 62, 63, 64, and so on. Okay. All right. I forgot to put one on there. And 64 and 6.5. So you can add that one on there too. Now I see some of you did shoe size going up and down, and some of you did shoe size horizontally, and that's fine. Okay? You still can get the same information. It's still the same information. The graphs may look just a little different. The scatter plots may look a little different, but that's okay. So why do you suppose they call this a scatter plot when you're doing it?
Because it's docile.
Yeah, they're kind of all over the place, right? Now, do you guys see sort of a little bit of a pattern with those dots, that your points that you're putting on there? Is there any pattern you're seeing?
The most centered around the 8.
Okay, there's some, you kind of have a lot that are very centered around the 8. Okay, they're kind of clustered together, is that right? Yes, is everybody seeing that there's some that are kind of clustered together when you graph it? And that actually was one of the questions that I had on here. And that's an important piece of information because that helps us. It says, are there any clusters of data? Yes. Because if we think about our mean, median, and mode, where is most of our data going to be in terms of where with things? It's going to be around those clusters, isn't it?
Yes.
Okay. So that helps us with some of that. The other question here is, are there any outliers? Are there any that kind of stick out a ways? Okay, which one? They aren't really part of the thing.
8.5 and 10.5.
The 70 and 10.5?
6.5.
Oh, this is 64 and 6.5? The two of those together. That one kind of sticks out a little bit away from everything. Okay. If I put like 70 and a shoe size of 6.5, would that be one that would kind of stick out?
Yeah.
It wouldn't kind of follow the pattern? And those are called outliers. When they don't follow the pattern, they're called outliers. So you guys might want to write those two things down. Clusters are when the points are kind of in a scatter plot are kind of close together. And your outliers is something that doesn't really go with what the rest of the data is showing. Okay? And then the other thing you guys said is you said that you're noticing a pattern. Even though they're kind of scattered all over the place, there's some sort of pattern that's happening. What's the pattern you're seeing? What kind of pattern are you kind of seeing? Mm-hmm.
I think there's a diagonal. I see a diagonal.
Okay, kind of almost following a line?
Yes.
Okay. And it's going up from...
From 61 to 72.
Yeah, so from the left side of the graph to the right side, it's going up, right? It's not going down. Okay, so it's going up. And when you see a pattern like that, that's called an association. If they were like all over the place and there was no pattern that was kind of happening, then you wouldn't have an association. So an association when there's a kind of a pattern that's happening with the points in the scatter plot. So make sure you get that down. You want to see, because that's one of the things you look for in scatter plots. People that do research and do all sorts of things with other kinds of things, they look for these kinds of associations and those patterns to see if there's something that's happening. Because when you're working with real data, things don't come out perfectly. And this is kind of almost making a sort of a straight line. So what kind of association? In this case, you guys noticed it was making a kind of a line, didn't you? So we call it a linear association. You also, what else?
It's going up.
It's going up. So is it a positive or negative association?
Positive.
It's positive, right. If it was going down, it would be a negative one. Good. Excellent. That's very similar to the information we did with graphing, isn't it? And so that is basically, and that's the last slide today. We just did 3 lessons, kind of put them together here, or 3 lessons in your thing and talked about them. And these are the big ideas and what you need to think about and be able to do. Okay? And you got to actually do some graphing and those kinds of things. How much of this stuff did I directly tell you? This is what you're supposed to do today? How much did you guys do though?
A lot.
A lot. Okay, so you guys have a lot more math knowledge up here sometimes, I think, than you have confidence with. You guys did a great job today. Before you go, though, you do need to do one thing. What's the last thing you have to do in your notes before you go? Essential question summary. Okay? So make sure you do that. And if you have any questions, if there's any questions, let me know. And I did have a question for our person on the other end, for Ashley, because I want to know if this was better in terms of hearing, being able to hear the teacher the way we did this today. So if you can let me know that, just type it in and I can see that on my end. Nobody else will see it. Or you can give me a thumbs up if you want, or a smiley face, or something, a check mark or something, so I know it was better. So I'm going to stop the recording.